Okay, Algebra 2 students, here's the first video for section 6.4, logarithmic functions. How is the relationship between logarithmic and exponential functions revealed in key features of their graphs? Graph logarithmic functions and find equations of the inverses of exponential and logarithmic functions. That's going to come right up in example 1. They want us to identify key features of logarithmic functions like the domain, range, x-intercept, and asymptote, and the end behavior. Okay, y equals log base 2 of x and y equals 2 to the x are inverse functions. Why they're telling us that? I guess if you know how to graph y equals 2 to the x and you know their inverses, it's just a reflection about the line y equals x, which would be right about here. So all these points, you just switch the xy's and they become here. Like negative 2.5, negative 2 for x yields a result of 0.25, and you plug a negative 1 in for x, you get 0.5. That's for y equals 2 to the x. It's just the opposite for log base 2 of x, which is the blue equation. Now they want us to identify the x-intercept. The x-intercept is 1. The asymptote, there's an asymptote here at the y-axis. I don't see one, even though it's going up very slowly, it's going up forever and ever. So there's no horizontal asymptote. The only one is a vertical asymptote. What else? End behavior. As x approaches infinity, y is approaching infinity. As x approaches negative infinity, well, kind of don't have that because we have the asymptote. Domain. The domain are only the positive values for x because we have no negative values for x. Range. It goes down to negative infinity and up to positive infinity, so it's all real numbers for the range. Alright. Let's see what we have here. Graph the function, identify the domain and range, list any intercepts and asymptotes, describe end behavior. I'm not sure how they want us to do this. We could graph e to the x and then do the reciprocal of it, the inverse of it, but I'm just going to type in the natural log of x and then look at it. Now maybe we need to zoom in, or maybe we can do a table set and decide where the graph goes. Let me do that. Let me go with starting at 0, going up by 1. That looks pretty good. Make that table. At 0, it's undefined. There's an error. At 1, it goes through 0. So at 1, it goes through 0. And at, what's another number to pick? How about at 2, it goes through 0.69. At 2, it goes through 0.69. That's pretty close. I don't know if I can get much better than that. So there it is. What do they want us to find? List any intercepts. The x-intercept is 1. Asymptotes. The y-axis is an asymptote, so x equals 0. There's no horizontal asymptote. Describe end behavior. As x approaches infinity, y approaches infinity. Whoops, that was a try it. Well, I don't know if we've really had enough practice. How about this one, though? You can do this one if you want. Graph this and list the intercepts or asymptotes and end behavior or domain and range. Oh, I didn't do that in the previous problem. Let me go back. So the domain, all values x such that x is greater than 0. For the range, it's all numbers. All right, click pause, give it a shot, come on back. All right, I'm going to type in for y equals. Now, if you just type in log, the base is 10. I don't want the base to be 10. I need the base to be a half. I could type in 1/2 to the x power and then do the inverse of it. I'm going to type in log of x, and then that whole quantity is divided by log of a half. That's another way of writing this. This could be log of x over log of a half. I don't know if that's come up in this math course or not. That might be because I'm studying for the math meet, and that's a category in the math meet. Graph it. It looks like it's going down like that. Let me do the table set. At 1, it equals 0. And at 4, it equals negative 2. At 4, it equals negative 2. Let's see what they have for a graph. At 1 equals 0, and at 4 it equals negative 2. Yep, so it's the same graph. Now that I know it's the same graph, I feel more comfortable about talking about the domain. The domain is all values x such as x is greater than 0. The range, all numbers, all real numbers. Intercepts has an intercept, x-intercept of 1. Asymptote, x equals 0 is an asymptote. Oh yeah, they had this where I could have moved the asymptote. No, I can't move it anymore. And end behavior. As x approaches infinity, y approaches negative infinity. Is that what they had, all those answers? Yes, 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 yes. Oh, I forgot about as x approaches negative, as x approaches 0. I guess instead of as x approaches negative infinity, we have to talk about as x approaches 0, y approaches infinity. And homework. 12 through 15 on pages 325 to 326. That's it for this video. Have a great day.